All right, permutations and combinations. So imagine for a moment that I had three things on my desk, and I do here in the actual classroom. I have tape, I have a stapler, and I have a pen. T, S, and P. Okay? I'm going to grab them here. Here's my tape, here's my stapler, and here's my pen. I'll make it a big thick pen so that you can see it easier. Well, the question was, how many different ways could I arrange these things? Obviously, just putting them out counts as one arrangement, and that's pen, tape, stapler, PTS. Would you please write that down? Just PTS. Now we're going to write out every possible combo, and then I'm going to show you the math way to figure this out. Because in the real world, you do not want to actually rearrange these things over and over and over again. All right, so there's pen, tape, stapler. Obviously, I could rearrange it. I'm just going to move the pen to the end. And now, actually, I should do this from your perspective. So from your perspective, you would read from left to right. Now I've got them right. Pen, tape, stapler. Okay? Now, from your perspective, left to right, if I move the pen to the other end, now what do we have? Write down those three things. Tape, stapler, pen. Do you get we can keep doing that over and over again? Well, we're gonna, so let's just finish it off here. Now, what other one could have had a P to start with? Pen first. Well, I'd swap these two. Stapler, tape. Would you please try to figure out the other three? There's three more that I haven't listed up there. There's PTS, TSP, PST. There's three more. If I were you, I'd figure out what to start with first. Start with a T, and there's one more combo that could start with T. Did you get that was TPS? And then what's the last thing we could start with, Alexis? Stapler first. That's like this, here. Stapler, and then pen, and then tape. Or stapler first, and then tape, and then pen. There are 6 of them. All right. Next thing you have to learn is how to do this with something called a permutation. Put a big P. Put a big P. You didn't do anything since I said that, so I know you don't have one. You got a big P there. Now we're going to put 3 things, choosing to take out 3 at a time. This is your total things, and this is how many of them you are choosing. 3P3. That's what you just did. It's a math problem called 3P3. Now there's permutation, which means that the order of these things matters. That was the whole point, is rearranging them. It's the order of them. Okay? Now I was doing 3, and that might be confusing you. So now I'm going to do 3P2. That's where I have 3 things, like I still do. Stapler, tape, pen. But I'm only going to take 2 of them at a time and pull them out. Like these 2. So I had 3 things, but I'm going to pull out 2 at a time. This is how many you're choosing out. Does that make sense to you? Now, if it's 3 things and I'm choosing out 2 at a time, then I'd have a different list. And it would go, well, in this case, stapler and then tape. Or I could reverse them. Tape and stapler. Or I could pull out a different 2 things. Out of the 3 things, I could pull out the pen and the tape. So that would be tape, pen, or reverse them. Pen, tape, and then the last thing is I could pull out the 2 that I haven't pulled out yet. Somebody's probably got it in their head. Which are the 2 that I got to pull out now? Tyler, do you know which one I haven't pulled out yet? All right, stapler and pen. All right, stapler, pen, or I could reverse them. Pen, stapler. Now, the answer to that was 6. Is the answer just always 6? No, I'm going to show you how to get the answers for these. All right, so underneath this 3p2, I would like you to write out this little equation because this is how you figure these things out. You need one good example of this. So 3p2 is 3 with an exclamation mark. Does anybody in the room know what that means? If that was on the ACT and they just said, what's 3 exclamation? You know what to do? It's actually super easy, and this is good that you're learning this. Yes?
I think it's like, isn't it just like 3 times 2 times 1?
That's exactly what that means. 3 times 2 times 1. So 6 factorial will be 6 times 5 times 4 times 3 times 2 times 1. 2 factorial, just 2 times 1. So it's whatever the number is, like let's say it's a 5 factorial. The factorial means the exclamation mark, and you just go 5, 4, 3, 2, 1, all multiplied. Okay? If you've never heard of this before, that key, that's not a key, but it's underneath one of the keys on your calculator. There's a way to do that on your calculator. It's under the math key, and there's an exclamation mark. So let's say it was 7 factorial. Do you really want to do 7 times 6 times 5 times 4 times 3 times 2 times 1 in your head? Probably not. So if I were you, I'd grab your graphing calculator or get into the graphing calculator that is provided in my yellow folder, in the welcome folder, you know, yellow folder, and then you hit enter a few times and you're into that graphing calculator. Under the math key, look for the math key. Then you go to the PRB menu, that stands for probability, PRB, at the tab across the top. You know, after you hit math, you go to the probability section. Then you're looking for the exclamation mark. Do you see it in there? Does anybody see it in there? Yes, you can verify it's there. Good. So like if you do 3 factorial, you type in a 3, you make that exclamation mark, it should give you 6. Okay, now, I wish that this was that simple, just teaching you what a factorial is, but it's more complicated than that. Now, these happen in the real world too. It's not just some math teacher mumbling on about staplers and pens and stuff. This actually happens in the real world when you have books on a shelf, for example. Do you get almost everybody in here has got a shelf somewhere at home in your apartment or your house that's got a bunch of things on it. Could be books in a shelf. A lot of people have books in a shelf. Then you could rearrange those in how many different ways? Well, it's not just as simple as this. You can't just go whatever the number is factorial. You gotta also do the bottom part of the equation, which goes like this. Everybody finish off this equation with me now. 3 minus 2 parentheses factorial. How did I get those? This one minus this one. On the bottom. So it's 3 factorial over 3 minus 2 factorial. That simplifies to 3 factorial over 3 minus 2 is 1 factorial. If you had to guess what 1 factorial is, what do you guess that it is? 1 is correct, yes. So this is 3 times 2 times 1 over 1 factorial is just 1, so that's why the answer was 6. And I have all 6 of them listed right here for you. 1, 2, 3, 4, 5, and 6. Okay? But let me show you, and you'll get good at this after just a couple minutes. Let me show you. Let's say I had 7 things, but I'm going to pick out 2 at a time. The answer's not 6. Let me show you how it would work. Everybody write this. 7 factorial over 5 factorial. Where the heck did the 5 come from, Mr. Server? Oh yeah, it must be the 7 minus the 2, and that's correct. But there's this fast way and the slow way to do these. The slow way is the calculator. Now, I know you might be like, but I like the calculator. Well, it's going to be complicated because You're not going to be able to keep up with me if I do this. Here's the fast way. And I'm going to just put dot, 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 because I know it's going to keep going forever, right? 7, 6, 5, 4, 3, 2, 1 over 5 times 4 times dot, 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 dot. It's going to keep going forever, right? Do you get these guys are all going to cancel each other out? Do you get what I mean? Maybe I should just write them all the way out. 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. I know some of you would be sick of writing after a while, and you could do what I did there. But this is exactly what happened. All of those canceled, and the answer is 7 times 6, which is 42. I didn't need a calculator. See what I mean? There's 42 different ways to do that. What would this be like in the real world, Mr. Server? I take 7 kids in here. I offer, okay, just for entertainment, let's go out in the parking lot and let's have a race. And some of you are like, I'm not racing anybody. And there's 7 kids that say, yeah, I'll race. That sounds good. Okay? And me and 6 kids race across the parking lot. We could have a prize for first and second place. That's exactly what this is. 7 people racing, 2 places counted. There's 42 different ways that could happen. Of course, I would get first place. Maybe not. Let's say that I come in second place and there's some other kid comes in first place. That's one of the many ways that it could happen. Or I could come in first and some other kid come in second. Or I could not even be in the top, which is probably wouldn't realistically. Maybe back in my prime, but not now. So there's a whole bunch of different ways it could happen. How many ways? 42 ways that could happen. 7 people in a race, 2 places. Yes?
Just out of curiosity, how long would the race be?
I was picturing just across the parking lot, like maybe a 100-yard dash kind of a thing. Now, we're not actually going to do this because my liability brain kicks in, and I actually ran in a parking lot one time and got hurt really bad. You know why? I was going really fast and I hit some loose gravel. You might be like, why were you running in a parking lot? Back when I was in middle school teacher, I would go out at lunchtime, and play with the kids, just kind of keep them occupied during lunch. They'd eat lunch quick and then they'd go out and play a thing that I made up called server ball. It was kind of like soccer, except you could use your hands. So it was kind of interesting. It was fun. And kind of passed the time for a lot of kids. Had some fun out there, got their aggressions out, and we went back in until the one day that Mr. Server wiped really hard. It's huge, scraped my leg up bad because loose gravel in the parking lot. So if I actually brought you out there and one of you like pulled a hamstring, somebody else gets hit by a car, third kid wipes out on some gravel, all of a sudden I'm in trouble. So anyways, you could imagine it though. All right, I'm going to give you one more scenario. Let's see if you got this. Let's say this is all of you guys, which is, there's about 30 of us in here today. Okay. Let's say that there's 30. I'm just going to make it a nice round number. And we are going to pick a president and a vice president of the class. There can only be one president, and there can only be one vice president. And so therefore, we're choosing out 2 distinct things. And does it matter if you reverse it? Yeah, that'd be different. Like, let's say you're president and he's vice president. If you reverse those, that's quite different. All of a sudden, you're not president anymore, so it's different, the distinct differences. So therefore, it's a permutation. The order of it matters. You can't say Bob, Sarah, and then Sarah, Bob's not the same. That's different. So 30 of you, P2. Now, do I want to do this by hand? No. Let me show you why not. 30 factorial over, have you figured this out yet? Is it 2 factorial? No. What's on the bottom? 28 factorial. Now, I could do some of it in my head. I could go, this would be like 30 times 29 times 28 times 27, dot, dot, dot. I could write out just the first few of them, and this one would be 28 times 27 times dot, 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 dot. And then I get the idea. Look at that. These cancel. The answer is 30 times 29, but I still would want a calculator, even with that. But there is a calculator way to do this. Do you have the answer for it? Oh, yes, okay. And then let's do this one with the calculator. So let's show you where that is. It's under math. PRB. PRB is like a menu across the top. It's like a tab. So you kind of hit right arrow, I think it is. And then you're looking for the factorial button. And if you're in the iPad's normal calculator, I don't think they have one. And if they do, I'd love to know. If you're not, if you're in the one that I was suggesting, you go to the welcome folder and then the yellow folder, and then it says, if you want a calculator, click here. We used that recently. That kind of calculator is what I was describing, a TI-84, TI-83 kind. Yes?
879.
Thank you. All right. Now, you ready for this? That can also be put into the calculator in another way. I don't even know if we're going to allow this on the test. It's that helpful. So it's like top secret. I don't know if I should be telling you this, but I think it's okay. Knowledge is power, right? So here's what you could do. Under math, PRB, do you see the one that's called NPR? On your calculator, you see on the calculator? If you're not there on the calculator, I'm going to be mad at you in a moment when I walk out there and you're like, well, I don't know, I actually had to go to the calculator. Yes, you needed to go to the calculator or you needed to have one in your hand. I'm okay with either of those options, but get there quickly, please. Now, NPR is one of the choices under the PRB menu, that stands for probability, which is under the math menu. So you go into math, PRB, NPR. Next, you would type in 28, and then you hit the NPR thing, and then you type in 28. So I'm wrong, dang it, it's 30 first. If you did that wrong, you could just go back and arrow on top of it and retype 30, and then arrow to the end and put 28. That's what I'm asking you to do right now, and it should also come up to 870 if that answer was right. Would you please do this on the calculator? I will walk past if you are having tech issues, and I'm going to pause for a minute while I help people with tech issues. Sorry about that. I had the first kid tell me that I typed that wrong. That is not supposed to be a 28. It's supposed to be a 2. 30p, 2. Everybody try that. And it should come out to 870. Yes?
How would you do the question of the TI-83?
The question with the what?
The TI-83.
All right. Yes, you could use a TI-83. So the first thing you'd hit is the math button. You got that? Okay. So there's a math button on there. Look for the one that says MATH on it. Okay. Hit that. Hit PRB. And I think you arrow once to the right. And it'll bring you to the PRB menu. And then, not this thing though. You look for NPR, which looks like this. You see that on there? Okay. Then you've got to get a number in front of it. You can do that by inserting a number, or you can start by typing 30. Then you hit exactly this key sequence. Math key first, PRB key next, the NPR key third, and then you get to type your other number, 2. So we're doing 30, NPR 2, and the final answer should be 870. All right, I'm going to pause for a second and make sure you can all get that. Now that I made sure everybody can do that, I just want to do one more to lock it in, make sure you really get this. Here's a word problem. 10 friends are out in Lake Minnetonka bobbing around in the water because they jumped off of a boat and they're having just a swim out there for fun, and they're going to go into Licks afterwards and Excelsior and have some ice cream. And in the meantime, though, they decide to have a little race around the boat. So they all start together in a pack, and then they're going to swim around the boat and see who comes in first, second, and third as they go around the boat. By the way, would you want the inside track or the outside track? The inside would be faster. Okay. So imagine for a moment you got this race of 10 kids, and they're going around this boat. Do you get they're going to come in first, second, third, fourth, etc.? But it's going to be more complicated to keep track of more than 3 places. But let's just say that there's 3 places. First, second, and third. So you got 10 people. P, 3 places. How many different ways could they finish? It could be Bob, Sarah, Jim. It could be Jim, Bob, Billy, it could be so many different ways, okay? Would you try and figure out, please, what 10p3 is using the technique I just showed you, and compare with the kid next to you and see if you get the same thing. Pausing for a second while you try that. So now I'm doing it on my calculator. Hit type 10 first, then I go to math, arrow over to probability. Sometimes it's abbreviated PROB, sometimes it's abbreviated PRB, depends on how old your calculator is. Then I go to NPR, and then 3. And I get 720. Is that serious? Yes, it is. Here's another way to do it, and let me see if you understand this way better. Would you agree there's 3 places, and there was 10 choices for who could win first place? Does that make sense to you? Would you agree after that first place winner is done, now there's only 9 choices of who could win second place? And only 8 who could win third. And look at that, 9 times 8 is 72, times 10 is 720. Couldn't we just do that, Mr. Server? Yeah, sometimes. So this is probability, where a lot of different things happen. And here's one of the problems that really blows people's minds. Would you agree there are 52 cards in a normal deck of cards? If I do this, 52p, 52, that's how many different ways could a deck be shuffled so that you're going to take all 52 cards out in a certain order. In other words, you just shuffle the deck. That's 52p52. Try it. Use your calculator and tell me what 52p52 is. It's going to be big. Yes?
8.06 times 10 is 67.
Now I have to move that decimal 67 spots over. I won't even be able to write that many zeros. That's what that means. That is so many different ways to shuffle a deck of cards. Just one deck of cards. That people that did the math on this, and it would take me a whole rest of the hour to show you, and you'd get really bored, but I'll just sum to the end. Since cards had been invented, if every person on the planet had a deck of cards and was just shuffling and pulling out all the possible orders, we still would not have had every possible order come up yet. So if you shuffle a deck of cards, it is very possible that after you shuffled it 3-4 times and you got this set, right, that nobody's ever seen it in that order before in history. Because that number is so big. There are so many different ways to arrange that deck. It's mind-blowing. Get how that's kind of crazy? Like, you would think that, I shuffled the deck, you shuffled the deck, this other kid shuffles the deck, and if you had a whole bunch of people doing that, it wouldn't be too long before they would repeat. No, it would be years and years and years and years and years and years. And before we got every single possible combo, in fact, we don't think we have. There's combos that have never been done before, even if everybody had been shuffling this entire time. It's crazy. So permutations get really big. So this was an example of you and 10 of your friends, and it was 720 different ways it could have happened. It could be Bob, Sarah, and Emil, and it could be Emil, Bob, and whatever. It could be all these different combinations. There's so many. That's called permutations. All right, I'm going to give you one last one that I think will blow your mind. Bus rolls up right outside here, and we all get off the bus, or we all get out, and we pile on a bus. Do you know how many people a typical bus can hold? You ever noticed it on the side? It usually says the capacity on the side of the bus. Ever notice it? Depends on the bus. But it could be anywhere between 50 and 60-ish kids. I've seen 52, I've seen 55. I'm sure you're probably right, these extra long ones are 64. But let's imagine for a moment that we get that many people, just enough to hold the whole bus. And let's keep it really simple. Let's say it's 55 kids. So that's our class plus a few more people, okay? and we go out and pile on the bus. Would you agree that that is one order that you could be in? And then that takes, let's say it takes a minute to get everybody back off the bus and then everybody back on the bus in a different order. 1 minute per time. That'd be moving pretty fast. You'd have to be like fire drill style, getting off the bus and then back on the bus. Do you know how long it would take to try every possible order? $24 hours? A week? Yes?
Roughly the same time in minutes as the card equation.
The same time in minutes as that card equation, except this is a little bigger. It'd actually be 55, what? P55. And that is such a big number, and then that's in minutes, and just to clarify, it would take your entire lifetime. The lifetimes of all 55 people would expire before we could finish. Isn't that insane? I would have thought you could do every possible combo of seats on the bus in like a couple days at most. No, it's your entire lifetime plus more. So permutations are big answers. Why? Because for that first seat in the bus, there's 55 choices. Times for the second seat in the bus, 54 choices. Then for the third seat on the bus, 53 choices. Times for the next seat on the bus, 52, 51, 50, and it's not just that though. It's that divided by something, but even so, it's 55 factorial divided by 55 minus 55, which is 0 factorial, which 0 factorial does equal something, by the way. It equals 1. It's a little known fact. So if you ever run into a 0 factorial, it's just 1. So if you wanted to load onto a bus, every kid gets out, shuffles back on, different spot, you'd never finish. You couldn't. Take more minutes than you have in your lifetime. Okay, I hope you feel like you learned something about permutations and combinations. There is a little worksheet, and this was the key formula for today. The first number goes here. The number on the bottom is this number minus that number. Would you please open that worksheet now? Keep your calculator up because you're allowed to use it. So I'd split screen and do it that way. Taylor, you got the first problem up yet? I just need somebody to read it to me. Come back to you in a minute. Truckee, have you got it up yet?
Yeah.
Excellent. Would you read me problem 1?
How many ways can the 8 books be arranged on the shelf?
This confuses a lot of people because they're like, 8p what, Mr. Server? What do you think the answer is? 8p what? 8. You're going to choose all the books and put them back on the shelf. 8p8. So how do you do that? Well, you could use a calculator, and I'd be fine with that. Or it would be 8 factorial over 8 minus 8 factorial, which is really 0 factorial, which equals 1. So then you're back to just 8 factorial again. Okay? I'm totally fine with you using a calculator to get this. It's big. And then write it out. Help me out, Kennedy. What did you get when you actually used the calc for it?
I got 40,220.
40320? Did I hear you right? Okay, good. Anybody else verify that number? Okay, good. Thank you. Number 2, Kennedy, could you read it for me?
How many ways can the books be arranged so that volume 5 will be the rightmost book?
Ooh. Everybody make 8 blanks. Remember I gave you that blanks way of doing it? This is where that way comes in handy. Did you say the rightmost book had to be a certain book?
Volume 5.
So there's only one choice for the rightmost book. It's not 5 choices, it's volume 5. It has to be that one. It'd be kind of like this. We're having a picture and there's 2 really tall people. Maybe you want them as bookends. Maybe you want them in the middle, but you don't just want them anywhere if you want the picture to look nice. It'll look weird if you have like just, one person that's tall kind of randomly. You'd like to make it more like symmetry. So anyway, there's only one choice for the end. How many choices for this spot then? Where there were how many people? Say it out loud. How many people were there?
None, never booked.
Okay, how many books were there? Sorry.
8.
8. Then there's, I gotta make sure I got the right number of blanks here. 1, 2, 3, 4, 5, 6, 7. I do. Then there's how many choices for this spot right here? More than 2. 7. There it is. Because we already used up one book right here, then there's 7 choices for that spot. And 6 and 5 and 4 and 3 and 2, and there'd only be one book left, so it has to go here. Do you get how I did that? I said this has to be a 1, and then I said how many choices do I have left, and then how many choices do I have left. And one of the things about probability is you always multiply choices. All right, we've seen this test, a question come up on lots of ACT. Let me give you one more that's kind of like it. I'm gonna do that picture one. Let's say I get 4 kids up here and 2 of them are tall. So I say, out of these 4 spots, I want this one kid here and this one kid here. So I only have one choice for each of those 2. How many choices do I have for the other spots? Well, there's 2 people left. I could choose 2 for that one. And then there's only one kid left because I've already got 3 of the 4 kids picked. So, see how that worked? I only had one choice for this in this spot because I wanted this one kid, tall kid on the end. Okay, I can even make it more complicated. I got 4 people, 2 of them are tall, and I don't care who stands on this end or this end as long as it's one of the 2 tall people. Then I have 2 choices for this spot and 1 choice for that spot because there were 2 tall people. Then there's 2 shorter people, and there's 2 choices for this spot and 1 choice for that spot. Or you could reverse these 2, I don't care. That's how you could do it with blanks. So that's the other powerful thing here. You got this formula, and you got blanks. And blanks are handy in some situations where you say, there's only 3 choices for this end spot. And then you'd have to go, okay, then there's how many more choices for the rest of the spots? 5, 4, 3, 2, 1. For example. That's if there was 8 people and you said ahead of time, I want it to be Bob, Sarah, or Jim on the end here. You force it to be 3 choices. Then you just put all the rest of them in a descending order like that. Okay, you've done permutations, you got a worksheet, it's pretty short, you probably finish it easily before the end of the hour. If you get stuck, please come up and ask. I'm not chopping any off because this is short. If you need help, please just ask me. That's all I got for the video for today.